Hi, I'm Adolph Oliver, and in this lesson we start our study of the methods of solving equations. We're going to start out with simple ones, of course, which can be solved basically in one step. But first, let's remind you of what we'll be running into as we go further on. Equations, of course, have two sides, something in both sides of the equal sign, and that's what makes them act like a balance scale. So for instance, I could write down 3x plus 2 equals 17. Okay, there's a left side here and there's a right side, and they're equal to each other. So anything I do to the left side, I have to do to the right. Now, first off, let's point out to you that if this was the most complicated type of equation we ever ran into, you would need all of the fancy techniques we'll be showing you, because you can look at this one and just try a few values out in your head, and pretty soon you can figure out what value x has to be so the two sides balance. Okay, well, we want 3 times some number plus 2 equals 17. Well, it doesn't take you too long to figure out that this x over here has to be 5, because 3 times 5 is 15 plus 2 is 17. In other words, what we did was basically solve this equation by what mathematicians call inspection. You just look at it, try out some values in your head until you find the one that balances it. Well, of course, we're going to be running into equations that are a lot more involved in this, and so it's not possible to solve them all in your head. And so what we need to do is start building up the basic techniques to be able to work with all of these. So let's remind you of these basic things. The idea, of course, is it's all based on this balance scale principle. So for instance, let's say you had something like this: x minus 4 equals 8. Now, our goal is to end up with x all by itself over here, so we can just state what the answer is. So I've got to get rid of this plus 4. I want to change it to 0, so I just have x minus 0, which equals x. Well, what do you combine with minus 4 to make it into 0? You add 4 to it. And minus 4 and plus 4, of course, give you 0. X minus 0 is just x. But now, here's where the balance scale principle holds. If I've added 4 to the left side to maintain the balance, I've got to add 4 to the right side. Well, 8 plus 4 gives me 12. And you can see in the original problem that 12 is the correct answer here. 12 minus 4 definitely equals 8. But this is an example of adding something to both sides. Well, let's take a look at the same idea, but an example where instead we have to subtract things. Let's say we have something like this: y plus 3 equals 5. Okay, once again, we want to get the variable all by itself on the left, so I can just say y equals whatever the answer is. Just like in the previous example, we got down here to where we say x equals 12. Well, again, this is a simple thing you can figure out in your head, but let's focus on these basic steps, because we'll have to chain those together when we get equations that are more complicated than this first example we showed you up above. Well, the key again is to get rid of this plus 3, so I just have the y on the left. Well, what can you combine with plus 3 to turn it into 0? Well, you subtract 3. Minus 3 plus 3 gives you 0. Y plus 0 is just y. But once again, to maintain the balance, since we subtracted 3 from the left side, I've got to subtract 3 from the right side. 5 minus 3 gives me 2. And you can see again that that's the correct answer. If y is 2, 2 plus 3 certainly equals 5. So the idea is here, start getting used to these basic steps. We're going to be chaining these together as we look at more complicated equations as we go on. Now, of course, you can have something like this. Let's say I've got 3w equals 12. Well, again, you can figure this one out in your head, simple enough, but the idea is we want to talk about the basic method of being able to solve this. What I've got is 3 times my w. Well, I want to know what just a single w is. So To get rid of 3 times, you do the opposite operation. This, of course, is what we did up above. When we had a minus 4, we did the opposite. We added 4. When we had plus 3, we did the opposite and subtracted 3. Well, down here, the opposite of 3 times is to divide by 3. So here we go, and if I divide my left side by 3, the 3's reduce out here, and I get 1w over 1, which is just equal to w. But of course, if I divide the left side here by 3, I've got to do the same thing to the right side. So divide it by 3. 12 divided by 3 is 4. So there's my answer, w equals 4. Well, again, you can see that that's correct. 3 times 4 would indeed equal 12. Okay, one last example here. Let's say I've got z divided by 2 equals 5. Okay, once again, you can figure this one out in your head, but let's show you the basic step here. I want to get the z all by itself. Well, it's being divided by 2. What do we do? Of course, the opposite math operation. So I'll multiply this side by 2. And, of course, what happens then is I can just reduce out the 2's, and I end up with 1z over 1, which is just z. But if I multiply the left side by 2 to get rid of this dividing by 2, I've got to multiply the right side by 2 also to maintain the balance. So I'll put the 2 over here in parens, and 5 times 2 gives me 10, so I'm claiming that z equals 10. And of course, if you go back to the original problem, we had z divided by 2 equals 5. Well, of course, 10 divided by 2 does equal 5. So these are the basic steps that we're going to use to be able to solve equations. We'll be running the things much more complicated than what we see here, but these basic steps will get us through in all of these. Let's now start looking at some examples. Here's the first one coming up. Okay, we happen to have some decimals. Remember, in equations, we can have whole numbers, decimals, and fractions. All of these things show up in real life. Now, here's the key again. My goal here is to get the x all by itself on the left side. I've got plus 8.8. So what I want to do is change this into 0. How do I do it? I turn around and do the opposite of adding. I subtract 8.8. Now, plus 8.8 and minus 8.8 end up giving me 0. X plus 0 is just x, so I'm all set here to have my final answer. I always want the variable on the left by itself, so when I read the answer, I say x equals whatever the answer is. Okay, well, remember, we've got to maintain the balance scale. So since I subtracted 8.8 on the left side, I've got to subtract 8.8 on this side. Okay, well, 14.4 minus 8.8. Okay, I'd have to do a little bit of borrowing here. Borrow 1 from the 4th place here in the units place. Carry it over here. 14 minus 8 gives me 6. There's my decimal point, and then 13 minus 8 is 5. Well, again, if you go back and look at this, if you take 5.6 and add it to 8.8, you will indeed get 14.4. Well, of course, there are going to be some cases where we're going to have to do a little bit of cleaning up as we solve these things, and we'll be showing you some more tricks as we go along here. The first thing here, notice I've got 0.3 on the left, the equal sign, and an x minus a negative 1.3. There are 2 sides here, so this is a balance scale. Anytime you have the balance scale, you can solve for x. The first thing we do on here is use the rules, as we've learned in the past here, to combine these 2 minus signs. The 2 minus signs will combine to a single plus. So let's rewrite our equation here. The right side now is officially x plus 1.3. And of course, we've got 0.3 on the left. Well, notice this. We, of course, want to have the x on the left side over here so that when we verbalize the final answer, we'll say x equals whatever the number is. The x is on the wrong side. One of the things we can do to take care of this is a trick again from the balance scales. If you've got yourself a balance scale over here with two pans, here they are on the balance scale, okay, and they are in balance, then of course what you can do is take this pan, put it over on this side, this pan on this side, and it should still be in balance. Okay, in other words, being able to interchange the pans doesn't change the balance of the scale. Whatever weight is in this equals the weight that's in that one. Well, anything you can do in a balance scale, you can do in an equation. So over here, I'm simply going to interchange the sides. Write the x plus 1.3 on the left and the 0.3 on the right. This interchanging the sides is a trick that we'll use, and we'll, of course, learn some more advanced techniques as we go further on. Well, now I've got the x on the left like I want. I've got to get rid of the plus 1.3 because I want the x all by itself. The opposite of addition, of course, is subtraction, so I subtract 1.3. But, of course, if I do that to the left side, I've got to do the same thing to the right side and subtract 1.3 over here to maintain the balance. Well, on the left side, the plus 1.3 and the minus 1.3 zero out, so I got x plus 0, which is just x. Over here, by positive and negative parts, positive part is 0.3, the negative part is negative 1.3, the negative is bigger. It's bigger by how much? Bigger by 1, so negative wins by 1. The answer on this problem, negative 1. Well, here's a similar guy right here that we have to do the same type of thing to. Notice, of course, the x is on the wrong side, so we'll have to change the pans or change the sides in a moment. But first off, we've got a number with more than one sign in front of it. Here it is right here, so we have to use the rules to combine these signs. The plus and minus combine to a single minus, so I can rewrite this problem. The right side is x minus 2.4, and the left side remains at negative 6.5. Okay, now, of course, we have to have the x on the left side, so I'm going to switch the sides. And when you switch the sides, you don't change anything. You just copy what was on the right side here, now on the left, exactly the way it is. So x minus 2.4. And whatever was on the left side, just move it over to the right, negative 6.5. Okay, well, we're all set here. All we have to do is get the x by itself. I've got to get rid of this negative 2.4, so we do the opposite math operation. We add 2.4, but if you do it to the left, you've got to do the same thing to the right. Remember, balance scale, you must do the same thing to both sides. Well, here we go. The minus 2.4 and the plus 2.4 zero out, so x minus 0 is just x. Over here, we've got more negatives. The negative part is 6.5. The positive part is 2.4. So the negative's going to win, and let's see by what. I think it's 4.1. So x equals negative 4.1. Okay. Well, here's another little twist. There are no signs to correct on this one. Our variable's on the wrong side, so the first thing we're going to do is interchange the sides, swap the pans again. So 14 minus a equals 20. Okay, the next thing, of course, is we've got to get rid of this 14. Now, there's no sign in front of it. So again, if you don't see a sign, you assume it to be positive, so there it is. What we want to do is get rid of this plus 14 to get the a all by itself. So the thing to do here is the opposite of plus 14. We subtract 14. But if you do it to one side, you've got to do the same thing to the other side. So there it is. Now, these two guys zero out. We got 0 minus a, which is just minus a equals, and over here, 20 minus 14 gives me 6. Now, here's one more little problem we're going to run into. This minus in front of my variable a means that what I'm doing is saying what the opposite value of a is. Remember, a minus sign means take the opposite of. So the opposite of a equals plus 6. Well, folks don't want to know what the opposite of your variable is. They want to know what the actual value of the variable is. So here's what you can do in this one. Remember, if you don't see a number in front of your variable, you can always assume that there's a 1 there. Negative 1 times a, so you could put a 1 in. Well, now this reminds you what to be able to do here. I got to get rid of this negative 1 times the a. Well, what's the opposite of times? It's divide. So I'm going to divide by negative 1. Well, if I do that to the left side, I've got to do the same thing to the right side. So I'm dividing by negative 1 over here. Well, the two 1's cancel out. They're just equal to 1 anyway. The two minuses in the fraction combine to give you a single sign. So officially, I'll rub it in here by putting a plus in front of the a. Here it is. And then over on the right side, 6 divided by 1 is just 6. But we have a single minus sign in the fraction, so that means the answer is negative 6. Now, folks would normally just write this finally as a equals negative 6. Remember, if you don't see a sign in front of your variable, you assume it to be plus. And of course, if you don't see a number, you assume it to be 1. So what you're doing when you write this is you're telling folks what the actual value of one of your variables is. That's exactly what they want to know, a equals negative 6. Okay, well, next up, let's take a look at what we do when we have something that's being multiplied. Here we have negative 6 times x equals negative 24. Again, we've got two sides, so this is an equation. We can solve for the variable. Well, I want to get the x all by itself, but I've got negative 6 times x. How do I get rid of negative 6 times? I do the opposite operation, which is divide by negative 6. So here that is. Remember, I also want to get rid of that minus sign, so that's why I divide by negative 6. Well, of course, if I do that to the left, I've got to do it to the right. Well, here's what happens. The 6's cancel out. We end up with just 1 over 1. The two minuses give me a plus. So officially, I've got here plus 1x. And over on the right side, the two minuses combine to a single plus, and 24 divided by 6 is 4. Well, normally folks would just simplify the final answer here. The pluses in front you don't need to write. And of course, the 1 in front of the x, if I leave it off, folks are going to assume there's just 1x. So I'd write this as x equals 4. And if you go back in the original problem, you can see that that's correct. Negative 6 times 4, well, 6 times 4 is 24, and there's one minus sign, so that indeed equals negative 24. Now here's something that we're going to bump into fairly often. We've got our variable here, r, divided by 6 equals 16. Okay, well, r divided by 6, the one thing you can do here is the opposite of division, which is multiplication. We've seen that before. So if I turn around, I'll just extend this fraction bar and multiply the top by 6. Then, of course, the 6's are going to cancel out. Well, of course, if I multiply the left side here by 6, I've got to multiply the right side by 6 also. So the 6's cancel out on the left. We get officially a 1 downstairs and a 1 upstairs. 1r over 1 just equals r. That's what we want on the left side, our variable. And over here, 6 times 6 is 36. Carry the 3. 6 times 1 is 6. Plus 3 looks like r equals 96. So in the original problem, if you took 96 and divided by 6, that does indeed give you 16. Well, here's a little twist to this divide bit. Look at this problem. We've got the fraction 2/3 times b equals negative 2/9. What's happening to this b is it's being multiplied by 2 and it's being divided by 3. Well, what we can do is get rid of this multiply and divide all at once. There's a nice technique for doing this. If you remember what a reciprocal is, we talked about these earlier, but a reciprocal means you just flip the fraction. Well, watch what happens if I multiply this left side by its reciprocal. Okay, what's the reciprocal again? The guy that's on the bottom you put on top. The guy that was on top you put him back on the bottom. Well, anytime you take a number and multiply it by a reciprocal, it multiplies to give you 1. Let's show you this. We can cross cancel the 3's here. We can also cross cancel the 2's. We end up with 1 over 1, which is just 1. It works beautifully just to give us b on the left. This is the nicest way to clear out a fraction, which is multiplying your variable. Well, now we still have to take care of the balance scale issue. I multiplied this left side by 3/2, so you got to multiply the right side by 3/2 also. Remember, this is to maintain the balance scale. Well, let's see what happens when we do this. We can do some cross canceling. This 2 cancels against this 2. The 3 here goes once here, but it goes 3 times into the 9. Notice I've got a single minus sign here, so the answer is going to be negative. Upstairs I have 1 times 1, which is 1, and downstairs 3 times 1, which is 3. There's our answer. B equals negative 1/3. Okay, well, let's look at one final example here. Remember, we're just doing the more simple equations here in this particular lesson. As we go on, we'll be dealing with things that are more complicated. This one here, we've got a couple of fractions in it. We're going to go ahead and solve it with these fractions, but we'll learn advanced techniques in the future. Here's the first issue. My variable n is on the wrong side. So the first thing I could do with this is interchange the sides, change the pans on the balance scale. And when you do that, you don't change anything on the side. You just move it completely over. So here it is exactly like it was here. And of course, move the other guy over. Here he goes. Now I've got the n on the correct side. But the first thing I've got to do is get rid of this other number. I want the variable n all by itself. Well, this is negative 11/8. I do the opposite of the minus, which is subtract. I'm going to add to this side positive 11/8. Well, of course, if I add plus 11/8 to one side, I've got to do the same to the other to maintain the balance. So here it is over here. Now again, notice what happens on the left. Negative 11/8 and positive 11/8 zero out. I end up with 0 minus n, or on the left side here, simply negative n. Now, over on the right side, we got to do a little bit of work. We can't combine or add or subtract these fractions because they do not have a common denominator. Well, what is the common denominator? We start looking at multiples of the largest denominator, which is 40. The first multiple of 40 is 40, and 8 divides evenly into 40, so we want both these guys into 40ths. Well, let me just go ahead and write over here what they are. Notice this guy here is already at 40ths, so he remains 61 over 40. But this guy here, I've got to multiply top and bottom by 5. If I multiply the top by 5, I get 55. I multiply the bottom by 5, I get 40. Now notice, we can check this to make sure it's correct. If I reduce to 5 top and bottom on this, 5 would go into 55 11 times, 5 would go into 48 times. So this 55 over 40 is exactly the same as 11 over 8. I've just rewritten it now so it has this common denominator I need. Now remember, of course, this is positive. So what we're doing is we're combining both of these guys. So we can now do that. We're going to end up with a positive. I'll put the plus here just to rub it in. 61 and 55, adding these together, 5 and 1 is 6. 5 and 6 is 11. I end up with 116 over 40. Okay, now, well, again, we had a problem like we had earlier. There's a minus sign in front of this variable. That means that what we're officially telling everybody here is that we've got the opposite of n equal to this. Well, you can figure out what's going on. If the opposite of n equals positive 116 over 40, then the actual value of n would have to equal negative 116 over 40. But let's show this to you officially. Here's what we can do now. Remember, this is officially minus 1 times n. I can put a 1 in there. Well, there are different ways. I could divide by negative 1, but the object is to turn this into a plus 1. So notice, here's another technique you could do. I could turn around and multiply this left side by negative 1, and this will also work. What's negative 1 times negative 1? Well, positive 1. And so there's my variable with the plus 1 I want in front of it. So I'm going to be quoting the actual value of one of the variables, and that's what people want to know for the answer. Well, if I multiplied the left side by negative 1 to do this, I've got to multiply the right side by negative 1. Well, 1 times this fraction just gives me the fraction back, but notice plus times minus means the answer is negative 116 over 40. Well, one last thing, you better not leave the answer like this, because we have this standing rule that you always have to be able to reduce fractions when they show up in final answers. So, on the left side, the plus 1 n, I can just write it simply as n. The right side is negative, but now, since these are both even, let me start out by reducing top and bottom by 2 here. 2 goes into 116. Let's see, I think that's going to be 58 times. I'll kind of write it on the side here. 2 goes into 40 20 times. Okay, well, that means I've got negative 58 over 20. Well, guess what? This can be reduced further. And, of course, you've always got to reduce it as much as you can. So, since they're both even, let's reduce a 2 into both again. 2 goes into 58 29 times. 2 goes into 20 10 times. So now I'm down to my answer being n equals negative 29 over 10. Okay, well, at this stage, there's no more reducing that we can do. 10 is 2 times 5, and neither one of those will reduce into 29. So my final answer is right here. Now, this is an improper fraction. The value is greater than 1 because the top is larger than the bottom. But in the algebra, as long as it's not a word problem or later on we're not graphing, you can leave the answer in improper form here. You don't have to make a mixed number. You can if you want, but it's not necessary. This is perfectly fine here. N equals negative 29 tenths.